All right, our next task is to talk about how to translate between the two scales, the data scale, the x's, and the standard scale, the z's. So let's suppose we have a normally distributed population. And let's suppose we are given, for now, the mean and the standard deviation must be given in the problem. So everything we're doing for now, for quite a while now, the values must be given. So suppose we're given mu to be, let's say something easy like 40, and the standard deviation is, let's say it's 3. So the center is at mu equal 40. This is the data scale. This is the standard scale, and we know the standard scale is centered at 0. The standard scale is always centered at 0. Values to the right of 0 on this z scale, these values must be positive. Values to the left of 0 on the z scale must be negative. On the x-axis, anything goes. Anything on either side of the interval may be positive, negative. This is just an ordinary number line. So the values over here, so this is 40, there are values over here going to be in the 40s and the 50s. Values over here will be in the 30s and the 20s. But values on the z scale to the left of 0, these must be negative. Values on the z scale to the right of 0 must be positive. And let's suppose we have a data value. Suppose we're given x equal to, let's say, 48. So 48 is, let's say it's over here. When you're labeling these pictures, you do not need to worry about getting it to scale. All you need to make sure is to remember that the x-axis is a number line. So if this is 40, 48 is to the right of 40. I don't know all the mathematics in the world. I know 48 is more than 40. Pretty soon we're going to deal with our next example. Let's suppose x is going to be 35. Well, I know 35 needs to be over here. Don't worry about how far this is compared to how far that is. The relative size, the scaling is not what's important. What matters is that you get 48 is bigger than 40 and 35 is to the left of 40. So what we're going to do is take in each of these one by one, we'll take each of these and translate from the x scale to the z scale. And this is it. This is the big formula that translates the whole set of numbers from the x scale to the z scale. It is this. Z is equal to x minus mu over sigma. You don't need to have that formula memorized, but you'll end up memorizing it because you'll be using it so often. For the record, you don't have to have it memorized, but there it is. This is this was the translation between the x scale and the z scale. And so, suppose we're given x equals 48. We've already been given that mu is equal to 40 and the standard deviation is equal to 3. So the question is, what value on the z scale corresponds to 48 on the x scale? How do you translate 48 from the x language to the z language? And that translation is made by this formula. It's simply plug the values in and compute. So z is equal to the x value, which is 48, minus mu, which is 40, all of the standard deviation, which is 3. Now, your calculator knows the order of operations even if you don't. So the safe thing to do is compute the numerator, hit equals, that's 8, over the denominator is still 3, and then 8 divided by 3 is 2 point. Now, if you look on your calculator, it will say 6, 6, 6, 6, continuing on. For our purposes, until further notice, everything we do with z-scores, requires 2 decimals. You'll see why here in a little bit, but for now, round everything to 2 decimals. Don't use 2.66. Use 2.67. So for our purposes, our z-score is going to be 2.67. 48 in the x language corresponds to 2.67 in the z language. It's the x value, which in this case is given, minus mu all divided by sigma. Remember, for our purposes for now, sigma and mu must both be given. So the question is, can you translate 35? 35. So for problem number 2, if x is 35, use the same mu and sigma as 40 and 30. So in this scenario, z would equal, I'm going to find now this number. Now, one thing we know before we even start, this number must be negative because it is to the left of 0. 40 is centered at 0. And so 48 must be a number bigger than 0. 35 must be some number smaller than 0. We're going to find it right now. So z is x minus mu over sigma, which in this case is 35 minus mu is 40 over sigma is 3. Again, be very careful. Put 35 minus 40, hit equals, and then divide that by 3. This becomes negative 5 over 3, which is negative 1.66666. And the same rules we're going to use before. You round to 2 decimals. So for our purposes, this will be negative 1.67. So for now, so far, that's all you need to be able to do. Given mu and sigma, and given specific values on the x-axis, you should be able to find the z-scores to which they correspond.